Hello all and welcome back. So in this video, let us now continue our discussion and now let's try to understand different kinds of graph. So in the last video, we specifically discussed about some terminologies which help us to define different components which are present in a graph. Now we are talking about different types of graph, like based on some property, how the graph can be of one type or the another. So let's get started everyone. The very first one, as we can see, is undirected basically graph, right? So let me correct it. It's undirected graph. The understanding is very simple. We have a few nodes. Okay, let's say we have node like this. Here we don't have any direction on the edges. Okay, so it's a graph where this edge, this edge, this edge. Let's say if it is like this, both the all the edges they are bidirectional. That is, they don't have any direction. You can go from, let's say if it is A and B, you can go from A to B and come back from B to A as well. So this kind of a graph where no directions are there on edges, that is known as undirected graph. Okay. The opposite of that, of course, is the directed graph. Now in directed graph, we have some directions, right? So for example, let's say this is B, or let me take it as D and E. If we have some edge which has a direction associated, then it's a directed graph, right? So let me just explain you this again via visual aid. So if we go here, if I make it undirected, then you will see that all these nodes, they are just connected to each other just by edges. The second I make it directed, you will see the arrows coming, right? So see the reference, everyone. Now what is happening here is that from 1 to 5 you can go because there is a direction added. And if I have to go from 5 to 1, I have to add this direction. Okay. So again, the best way of thinking about this is the follow in our Instagram or any other social networking website. If you are following someone, doesn't mean that he or she is also following you. It's a single, or I would say directed approach. It's a directed graph, right? As compared to being friends on Facebook, where if you are friends with someone, he is also a friend with you. Okay, so I think we should write this example. That's a very helpful example. Let me write that down. Undirected is basically friends on Facebook or any other social network website, right? And it is follow on Instagram or LinkedIn. Great. Now the next one is a weighted or unweighted graph. Again, the understanding is very simple. What happened? Like, let's say if we have some map, okay, and we have some city, let's say from Delhi, then it gets connected to Mumbai, right? Now there is a distance or some weight which is associated, right? So from Delhi to it can happen that, let's say Haryana is pretty near to it. So the distance overall is going to be 200, for example, and it can be 500. We have added some weight to our overall edge. Normally, this can be a distance, this can be some weight overall with respect to any other magnitude, but the idea is that each and every edge is not same. In this kind of example, these edges were same in terms of their magnitude, right? But here we can say that, hey, if you have to go from Delhi to Haryana, it will be nearer because our edges have weight. In a similar way, we have the unweighted graph as well. So let us see that as well, everyone. The unweighted one is actually in front of you. What we can do is we can add weight to this by, let's say, saying 3, something like this. Now what this effectively does, it is adding some weight, if you will see, right? Again, that is not the length specifically. Don't think like this will be the length. Like if 100 is there, then it should be greater than that. No, nothing like that. It's just that I'm adding some weight. Okay. Let us make this graph a little bit cleaner so that, yeah, I think this makes sense, kind of. Okay. So this is the kind of a graph which you can imagine. Here we have added the weight overall to my edges. Now let us move forward, everyone. Let us now learn about the cyclic and uncyclic graph. Unweighted and weighted, I'm pretty sure should be clear. Just the edges have weight. If they are not having any weight, no values, then it's an unweighted graph. Okay. So let us now move forward and learn about cyclic and acyclic. Let us first talk about the cyclic. So a cyclic graph is a graph that contains at least one cycle. Okay. So let me write that down. Cyclic implies contains one cycle at least. Now, what does a cycle means? It means that the path, okay, so the overall path that starts and end at the same vertex. So we can draw that as well, everyone. Pay attention. Let's say if I have some graph like this, where we have these four vertices. Let me draw them clearly and by copying one. So something like this. And if I just connect this kind of a graph, let's say by edges, and I'm able to make it start and stop at a particular same edge. So it is a cyclic graph now, right? Because I can start from here, then go like this. We can see the cycle as well. So this is a cycle, right? As compared, acyclic graph is a graph where no cycle can be there. Okay, so it does not contain any cycle. You cannot ever start with a particular, let's say, vertex or node and end up there as well if you go. Okay, so that thing is what a acyclic graph is. Now, next, let us talk about the completed graph. So, in a completed graph, every pair of vertices is connected by an edge, right? So, each and every vertex or the node is connected by an edge. So, let us see that as well. If I draw a completed graph, it will be something like this. So, I'm making sure that you get all this information in a single page so that it is easier to revise. Else, normally it becomes a lot difficult, right? So, that is the major aim on making sure that each and every information you have it here. Once you will be using it a lot, then it will get a lot clear. Okay, so this is the overall complete graph, everyone. Every overall node or vertex, it is connected, right, with an edge. So every pair of node and vertex, here you cannot say that any particular node, it is not connected to the other node. We will see that each and every node is connected to every other node. This is known as a completed graph. It is also sometimes called as a dense graph. Okay, because it has so many edges, rather all the edges which are possible here. So let us move forward now, everyone. The next one is a labeled graph. Now in a labeled graph, we have the labels on the nodes or an edge, right? So just to show an example, we can have a node here and I can have a node here. Let's say if they are connected, then I can have a label or I can maybe connect them with a red color overall. Okay, so instead of this yellow, I am saying that this is a red label. Okay, now here we can have another node and let's say they are connected with a green arrow. So I am just giving a label to my node or an edge. Now similarly, I can give labels to the node. Let's say this is some station 1, this is station 2. The label graph is different from a weighted graph in the sense that these labels, they need not to be numeric. In a weighted graph, overall, we should have the labels as non-negative integer, but that is not the case with your labeled graph. Here we are just adding any label, okay, to our graph or to our node or the edges. Now the last one is a connected graph. So a connected graph is a type of a graph where each vertex or a node have path to reach from one to another. Okay. So what does that mean in a simple language? That from a particular node or a vertex, you should be able to reach to the other node or a vertex. It should all be connected. Okay. So a very good example. Let me just draw it and add a new page. So something like this, if I am drawing, let's say this is my one node or vertex, then let me copy it. And we can have 4 of these vertices. Each and every one is connected to this, right? So they may not be directly connected, but now if you pay attention, from each and every node, let's say if I label them A, B, C, and D, from each node, I can go to the other node. if you ask me from going from A, can you go to D? Yes. Or to B? Yes. To C? Yes. It is now A to D is not a direct connection. A to C, it's not a direct connection, but still they are all connected, right? So it is not that any particular node is left which is not having any connection with the rest of the graph. So that is what is known as a connected graph, everyone. Okay, great. So I hope all the different kinds of graphs are clear. Let me just add an image as well, which will make it a lot more clear. So this image also again we can refer. Let me just make it a little bigger and try to quickly revise everything. So pay attention, everyone. Now this is the undirected graph, as we learned about. No directions, nothing as such. Then we have the directed graph where we have these directions. Sparse graph, just like we had a dense graph where each and every node were connected to the other node. Sparse graph is where these kind of overall nodes are not connected. Like it is a lot sparse. There are very less number of edges than there can be. Then we have the unweighted graph. We have the weighted graph, a cyclic graph, and a cyclic graph. Okay. So these are the different things which we have seen. Just one more thing to mention here. This is a loop. So when an edge starts, okay, and end at a particular node only, that is what is known as a loop, right? So there is an edge which is starting from A and ending at A, not going anywhere else. So this is known as a loop. Okay. So I hope that is clear, everyone. Now in the next video, we are going to see that how can we very effectively and efficiently try to code our graph, right? So as of now, we have discussed each and everything with respect to what a graph is, what are the different terminologies, and what are different kinds of graph. So in the next video now, let us make sure that based on this idea, based on this extensive understanding, how can we overall try to create a graph in our programming. Okay.